Hello everyone, welcome to this video on the concept of normality. In this video, we will learn to define normality and we will also learn about the terms associated to their definition of normality. So let's get started. Let us first of all understand why do we need to define yet another concentration term for a solution, that is normality. We will be taking the example of reaction between a base and an acid to understand this particular need. Okay. So in any base and acid, neutralization reaction occurs when they are mixed together. The neutralization reaction actually occurs between ions, that is provided by the base and acid respectively. The hydroxide ion comes from the base, whereas the H plus ion comes from the acid, and both of them combine together to give a neutral water molecule. This is the actual neutralization reaction, or we can say the actual reason for neutralization reaction. On doing stoichiometric balance, we will conclude that 1 mole of OH minus ion will require 1 mole of H plus ion to produce 1 mole of water molecule, which is neutralization. And this is how the neutralization reaction between an acid and a base takes place. Okay, so the OH minus ion is contributed by the respective base, sodium hydroxide in this example. Similarly, H plus ion is contributed by the respective acid, HCl in this example. So for any acid or for any base, we will be requiring the information such as how many moles of OH minus will be produced by 1 mole of that particular base. Okay, similarly, we will also like to know how many moles of H plus ion will be produced by 1 mole of that particular acid. Okay, these two quantities will help us to decide the respective amount of acid and a base in order to completely neutralize each other. Let us enhance this example a little bit more by introducing one more acid in our next example. So what do we do now? We introduce another acid, that is H2SO4, to neutralize same amount of sodium hydroxide. And we will notice from stoichiometry that to neutralize 1 mole of sodium hydroxide, we will require just half mole of H2SO4. Okay, so now what do we want to do is we would like to relate the amount of HCl and H2SO4 that will neutralize the same amount of base, that is NaOH. So we have kept the concentration of sodium hydroxide equal in both the cases, that is 1 mole right here, and we are calculating the amount of different acid that will just be sufficient to neutralize this given amount. So in case of HCl it is 1 mole, whereas in case of H2SO4 it is just half moles. Let us put a more formal definition to the amount of acids that we are trying to relate in order to neutralize a given amount of base. Let us take the example of HCl, H2SO4 and H3PO4. The property of acid that will help us to arrive at this relation is called basicity. We will be requiring to calculate the molar mass, and let us calculate the mass of the acid which will furnish 1 mole of H plus ion. Okay, so the basicity of HCl is 1, the basicity of H2SO4 is 2, and for S3PO4 is 3. This information tells us how many number of H plus ions mole will be furnished from 1 mole of respective acid. So 1 mole of HCl will furnish 1 mole of H plus ions. 1 mole of H2SO4 will furnish 2 moles of H plus ions, whereas 1 mole of H3PO4 will furnish 3 moles of H plus ions. So if we convert the mass of 1 mole of respective acid, it will give us the molar mass. So 1 mole of HCl will be equal to 36.5 gram. For H2SO4 it will be 98 gram, and for S3PO4 as well it will be 98 gram. Okay, so this much weight of respective acid will furnish the amount of H plus which is equal to its basicity. Now we are interested in knowing the amount of acid that will furnish just 1 mole of H plus ion. For HCl, it is going to be equal to its molar mass, because 36.5 gram of HCl will furnish 1 mole of H plus ion. However, for H2SO4, we saw 98 gram, that is equal to 1 mole, will give us 2 moles of H plus ion. Therefore, the mass required for 1 mole of H plus ion from H2SO4 will be half of its molar mass, that is 49 gram. And on similar grounds, the mass required for S3PO4 will be 32.66 gram. We will divide the molar mass by 3, its basicity. Okay, so this mass of acid that is required to furnish 1 mole of H plus ion, just 1 mole of H plus ion, is called the equivalent weight of respective acid. As an illustration, let us take the example of H2SO4, whose given mass is 196 grams. Molar mass of H2SO4 is 98 gram per mole. Therefore, we can calculate the number of moles as 196 gram divided by 98 gram per mole. It will be equal to 4 moles. Now if we have to calculate the number of equivalents, then we will divide this given weight by its equivalent weight, which is equal to 49 gram in this case. So 196 gram divided by 49 gram per equivalent will give us 8 equivalents of H2SO4. So 4 moles of H2SO4 tell us that the H plus ion that can be calculated from using mole balance will be 4 times 2, that will be equal to 8 moles of H plus ion, whereas 8 equivalent will tell us that the amount of H plus ion will be equal to 8 times 1, that will be equal to 8 moles of H plus ion. Okay, now if we prepare the solution of H2SO4 by dissolving 196 gram into 1 liter of water, then in terms of molarity the concentration will be equal to number of moles divided by volume, 4 moles divided by 1 liter, that will give us 4 molar solution. Whereas we can also express the concentration of this solution in a new concentration term that we define as normality, which is equal to the number of equivalents present in 1 liter of solution. So the number of equivalents right here is 8 divided by the given volume is 1 liter. So it will be labeled as 8 normal solution. Okay, so now we are prepared to define a new concentration term, normality, here. and hence we define normality as the concentration term which gives us the number of equivalents of a solute that is present in a unit volume of solution. As in the case of molarity, the unit used to express the volume is liter here as well. Okay, and now this new term number of equivalent is calculated as given weight of that particular solute divided by its equivalent weight, and equivalent weight again is calculated as molar mass divided by basicity. This definition of equivalent weight is for acid and it will change depending on the type of compound it is. We will see this in our coming videos. So in this video, we learned about the concept of equivalent weight and normality. In the upcoming video, we will be relating the two concentration terms, normality and molarity. Thank you so much for watching and see you in the next video.